Hello, dear student. Welcome to this new edition of online classes. Today we are going to continue with our chapter about network, hardware, and topology. As you know, the objective of this chapter are to help you to be able to define the different hardware components and also to identify the different type of cables that are used for connecting devices together for proper communication, and also the different ways in which components could be arranged to communicate in a network. And today we are going to continue with um, the network topologies. You remember last time we discussed in lesson 1 over 4, we discussed about uh, the network component, and we saw the workstations, the servers, the modem, network interface card, the multiplexer, the repeater, the bridges, the routers, hub, and switches. And I gave you an assignment about defining what was a gateway. And today we are going to move to network topologies. And I remember that in class we talked about what was a topology. I gave a definition of a topology, and I even explained, according to real life situation, what was a topology. So today, this is our plan. We're going to introduce by defining what is a network topology. Then we're going to explain the different types of network topology that we have. We're going to talk about the point-to-point topology. We're going to talk about the bus topology, the ring topology, and it's going to be very interesting. So please stay connected, stay attentive while we're moving forward. As introduction, I need to tell you that the configuration or the topology of a network is the key to identify the performance of a network. So when we talk about network performances, we need to talk about the topology. How are the different parts of the network connected together to give the best results that we can expect? So it's not only about the component, it's also about the way the components are gathered. So we can identify and we can say this network is very performant, it's faster. Okay, network topology is the way a network is arranged, including the physical or logical description of how links and nodes are set up to relate to each other. I mean, how are the different components of the network related to each other? How are they sending and receiving information? And it's very interesting. So there are numerous way of numerous way a network can be arranged. There are numerous way of arranging a network, all with different pros and cons, and some are more useful in certain circumstances than others. Meaning that we have different types of network topology, and according to the situation might be facing, you need either to use one network topology or another's, or you can mix two different network topology to bring out the best results that you need. Then think of your network as a city. So imagine your network as Yaoundé City, and the topology is like the road map, right? You can leave from Bastos and go to DENNY, but there's not only one path leading to McDenny from Bastos. You can go from Bastos to a region or province. You can still go and take over and take another road going from, I don't know, La Retraite. So you have many different roads that can bring you or can lead to McDenny. But according to the situation, you have to choose the appropriate roads to reach McDenny as fast as you can. So they will tell you that the fastest road is this one, but if there's a lot of traffic there, maybe another road will be better. So the layout of your network is important for several reasons. Above all, it plays an essential role in uh, how well your network functions. So it's very interesting to look at the layout of your network, the way your network is arranged. That's what we talk about the topology. Uh, Categories of network topology. In fact, the way a network is arranged can make or break network functionality, connectivity, and protection from downtime. Meaning that the way you arrange your network, the way you fix your network, you set up your network, can really make the difference. It can make the difference because in a certain topology, everything works perfectly, but when a link is broken, nothing is working anymore. While using another one who is more complex, maybe slower, will help you to resolve this problem. If a link is broken, they still have other paths to deliver the data. So topology can be placed in three categories, notably. We have physical, we have the signal, and we have the logical. So the physical network topology refers to the actual connections when we talk about the wires, the cables, etc., of how the network is arranged. How is it set up, the maintenance and provisioning tasks require insight into the physical network. We have the signal. The signal network topology describes the actual path that information moves in a network. It's more visual. And we have the logical. The logical network topology is a higher level idea of how the network is set up, including which nodes, when we talk about the node, we talk about the endpoints, which nodes connect to each other and in which ways, as well as how data is transmitted through the network. So the logical network topology includes any virtual and cloud resources. So when we talk about cloud services, we talk about like what your Google is doing. We're talking about the logical part of network topology. And we're going to see now the classification of network physical topology. So we are really talking about physical topology. And we start with point-to-point topology. That's the first one. Point-to-point topology is the simplest topology that connects two nodes directly together with a common link. Very simple. The entire bandwidth of the common links is reserved for transmission between those two nodes. Let me illustrate it from here. So this is a point-to-point topology. And we have device 1 connected directly to device 2. So the bandwidth, all the bandwidth available is dedicated to transmit data from device 1 to device 2 or from device 2 to device 1. There's nothing else in between. So this is the simplest topology that can ever exist when we talk about network, because network is communication of one or more computers in a configuration that we call the topology. Okay, so we have now what we call the second part is the bus topology. The bus topology orients all the devices on a network along a single cable running in a single direction from one end of the network to the other, which is why it's sometimes called a line topology or the backbone topology. So data flow on the network also follows the route of the cable, so moving in one direction. As you can see in this illustration, this is what we call a bus topology. We have one single cable that we call also the backbone or the line. This is the line or the backbone. And all the computer or the devices are connected on this line. That's what we call is the bus topology. Okay? So you can see this one is connected to the line, this one connected to the line, etc. They are all connected to this line that we call the backbone. So data flow on the network and also follows the route of the cable. So data will only flow from this computer to this one using this cable. So one way, one direction. Okay, so let's move forward. This is the bus topology. Now we can talk about the bus topology advantages. Like bus topologies are a good cost-effective choice for smaller networks because the layout is very simple. You have one cable and you connect all the devices on that cable. It allows all devices to be connected via a single coaxial or RG45 cable. If needed, more nodes can be easily added to the network by joining additional cables. Very simple. Because bus topology use a single cable to transmit data, they are somewhat vulnerable. If the cable experiences a failure, then the whole network goes down, which can be time-consuming and expensive to restore, which can be less of an issue with smaller network. So that's the disadvantages of bus topology. It's really difficult because when that line is broken, I mean, no computer here are going to be connected. You have a failure on this line, then nothing can move, right? Okay, so let's move forward. Now we have the ring topology. The ring topology is where nodes are arranged in a cycle or a ring. That cycle is called a ring. The data can travel through the ring network in either one direction or both directions, with each device having exactly two neighbors. So you will see with this illustration, it's very easy to understand. This is what we call the ring topology, and this cycle is also called the ring. Then you have this computer having a network and a neighbor from the right and a neighbor from the left. So all the devices within a ring topology having two neighbors, and the data flows according to this ring topology. Like you have this one. So most of the time, what we see is that we have one way information goes like this, one way. And most of the time, if we want to solve this problem of one direction flow, we need to go to build up a second layer network in the same ring topology for information to go counterclockwise, or the other way, clockwise, right? So sometimes we need to do that. So since each device is only connected to the ones on either side, when data is transmitted, the packets also travel along the cycles, moving through each of the intermediate nodes until they arrive their destination. If a large network is arranged in a ring topology, repeaters can be used to ensure packets arrive correctly without data loss. Even though it's popular, a ring topology is still vulnerable to failure without proper network management, since the flow of data transmission moves unidirectionally between nodes along each ring. If one node goes down, it can take the entire network with it. So the question of scalability should also be taken into consideration in a ring topology. All the devices on the network share bandwidth, so the addition of more devices can contribute to overall communications delay. As you can see, the data flows one direction. So imagine to send one of information for this computer to this one, it needs to go either this way, passing through this one before reaching here. And it goes unidirectionally, like this way. It means for the information or the answer to come back, we still need to send it like this. When information comes in, goes out, you can send it this way or this way. It will be difficult. You receive from this side and you send from this side. Okay? So it's not really interesting to have such kind of topology if you don't really know what you're doing. And if this one computer just fall, it will be difficult for the network to continue to be efficient. So that was the first part of it. I wanted us to discuss about the bus topology, then discuss about the ring topology. We are going to move forward in next lesson and discuss about the other types of network topology. So stay tuned while we are moving to the next lesson next week. Thank you very much, and may God bless you.